Greetings and welcome to Edu-ca-te. If you had watched our previous video on the classification of numbers, this will help you to further understand what we're going to be talking about today. We're going to be talking about surds. So remember, I'm sure in grade 9 you've learned that you can say 2 multiplied by 2 is equals to 2 squared is equals to 4. Therefore, the square root of 4 is equals to 2. Why do you say so? It's because 4 is made up of 2 and 2. Or maybe you'd say 6 squared is equals to 6 times 6 is equals to 36. Therefore, the root of 36 is equals to 6 because 36 is made up of 2 6's. So that's basically the roots and the square root thing. So square root is just basically reversing from this large number to break it down into its components as exactly what make up 36 in this case. So today we're going to be actually talking about surds. So not all numbers can have perfect squares. So what do I mean by perfect squares? You can see that this is a perfect square. This is a perfect square. Reason being, if you say the square root of a certain number, if it is rational, or rather if it is a whole number without any decimals. So a, for example, here's the root of a. The root of a supposedly gives you an answer of 0,5435109, all of those. So that is an irrational number. So if you find the square root of a certain number giving you an irrational number, then it means that it is not a perfect square. It is therefore called a surd. So you can have a perfect square when the value of the square root of that number it is equals to a whole number. Suppose the value of that is equals to 4. It therefore means that this is a perfect square. So this is the differentiation between perfect squares and surds. So that is how they are differentiated. So in this case, we're going to be talking about the surd. So as you know that the surd is already not a perfect square, it means it gives an irrational number after calculating it basically. So here we're going to just classify, or maybe to lay our surds between certain perfect squares. So for example, you've got the square root of 27. Many people tend to confuse the square root of 27 with its cube root and say that the answer is 3 there. No, it is not. So the square root of 27 is not a perfect square. So how do we then put it between, how do we then estimate its value? How do we then kind of estimate what is its value? So you have to look at the perfect square which is before it and after it. So you have to look for the value of this and this. So you can see that there is square root of 27. So you can just browse and see which perfect square can you find. Suppose if the square root of 25 is equals to 5. Therefore it means 5 times 5 is equals to 25. So the square root of 25 is just 2 units before the square root of 27. And then what else follows after 5? Since you have 5, you just go to 6 and say 6 squared, then you get 36. Therefore you know that the square root of 36, which is equals to 6, is just 9 units away from here. So this is plus 9. So when you're going to classify this set, or when you're going to position this set between the perfect squares, you have to write it in form of root of 25, which is equals to 5, root of 27, and then root of 36. So here you have classified them. So this is 5, this is 6. So now you know the value of your surd by estimating it. So if they are going to ask and say estimate the value of the surd would be equals to something which between 5 and 6. So it's something between 5 and 6. So it can be an irrational number which can be 5,7798, all that. So it can be 5,5, it can be 5,9, all that. So it means it is between the 5 and 6 here. So you can try this on your calculator to see what is the exact value of that surd. So here's another example. You are given a surd, they say is the square root of 40. So the square root of 40, you know that the square root of 40 is not a perfect square. You can prove that by you can try all numbers from 1 squared up to 10 squared. You won't find any square which will give you 40 in the whole numbers basically. Therefore, here in term you have to classify this set in between the rational, in between two perfect squares. So in this case, you have to just write down your root of 40. So you have to look for a number which is here and a number which is this side. So the square root of 40, let's look at the numbers or the perfect squares that are nearer 40. So we can see that 4 units before 40, we've got the root of 36. You can try 37, 38, 39. All of them will not have any perfect square. The only perfect square we have before the root of 40 is the root of 36. And then 9 units away, we have got root of 49, which is 6 here, which is here 7. So it means here we can actually classify this surd as between 6 and 7. So you can say it's 6 comma a certain number. So if you are going to use a calculator, you are not going to get any answer that is less than 6 or any answer that is more than 7. So it means the answer lies between 6 and 7, which are all whole numbers. So here, if they're going to, you're not going to get anything less here or something more over there. So it means it is between this. So that is the importance of classifying that. So if you're just going to find the answer on a calculator, it will give you 6,32456. So you can see this is an irrational number, and you can see that it's not less than 6, it is not greater than 7, so it is between 6 and 7. That is the importance of just positioning that set between two whole numbers so that you can see. Okay, so here's another example. You can have the root of 15. So let's try to look which numbers make up the root of 15, or let's try just to see if it is a surd or not. So there is no number that multiplies itself and gives you 15. There is no number that will say a times a is equals to 15 and still be a whole number. No. Therefore, we classify this as a surd. So if you are going to write these values here, you look at the perfect square that is found here and the perfect square that is found here. So you can see that here you've got root 15 in the center. Now you'll check root 16 just after 15 can give you 4. And then just before the root of 15, you can have the root of 9. Here can have the root of 9. So if you just see here, you've got 3 and you've got 4. Therefore, the root of 15 is going to be 3 comma a certain number. So here you're just positioning this surd. What did you say is just surd? It is because it is not a perfect square. So this surd must be put in between perfect squares so that you can determine its estimated value. So if we are going to try out this and use a calculator and say the root of 15 is going to give you 3,87298. So you can see that this is an irrational number. So this is how you position the surds in between perfect squares. Thank you for watching.